An inductor looks like a wire-wound coil. Inductors used in electronic circuits are classified into high-frequency inductors, filter inductors, and power inductors for power supply circuits. This video explains power inductors used for power supply circuits. Power inductors range from very small ones used in smartphones and smartwatches to large ones used in communication base stations, cloud servers, and automobile electronic circuits. These electronic circuits require a power supply. AC-DC converters and DC-DC converters are used in power supply circuits in many types of equipment. The major components of a DC-DC converter include a control IC, switching element, power inductor, and capacitor. A power conductor is designed to store a current in the form of magnetic energy when it is energized and release the energy when it is de-energized. The switching regulator of a DC-DC converter works on the basis of this property. To convert a voltage input, when the switching transistor S-switch high is set to on and S-switch low is set to off, the inductor L is energized and it stores energy. When the S-switch high turned off and the switch low is set turned on, the inductor outputs a current. The capacitor C adjusts its voltage level and supplies it to the resistant load. Now we look at how to read the inductor specifications. The details of the specification items are: nominal inductance and measuring frequency indicate the inductance at the measurement frequency. Inductance tolerance refers to the tolerance of the nominal inductance. Self-resonant frequency indicates the maximum frequency at which the inductor can effectively operate. DC resistance is the resistance to direct current. Saturation current is the rated current value at which the inductance value decreases to the specified rate from its initial value when DC current is applied. Temperature rise current is the current value that causes the temperature to rise from the initial value to the specified temperature when DC current is applied. Items 5, 6 may have a different definition depending on the type of inductor. The following explains the current characteristics that are often inquired about in inductor specifications. The saturation allowable current value indicates how the inductance value changes with the current flowing through the inductor. This chart shows the direct current value when the inductance value decreases by 30% from the initial value. However, please note that the condition varies depending on the manufacturer and the series of inductors. The temperature rise current is the current value that represents how much heat the inductor generates relative to the current flowing through the inductor. This chart shows the direct current value when the inductor temperature rises by 40 degrees Celsius. However, please note that each company has a different evaluation method for temperature rise provisions due to heat generation. The characteristics of an inductor vary depending on the material type of the core. There are two types of core material: ferrite and metal, and they both have their respective advantages and disadvantages. The ferrite material has the advantage of allowing a high inductance, but the disadvantage of not being suitable for relatively high current. The metal material has the advantage of being suitable for a high current, but the disadvantage of not allowing relatively high inductance. The following is an explanation of the differences in characteristics between the core material types. The saturation current level is subject to comparison for the ferrite and metal cores with the same size and inductance. Ferrite-based materials show a steep decrease in inductance value as they approach magnetic saturation, whereas metal-based materials show a gradual decrease overall. Let's take a look at changes in ambient temperature and changes in the inductance in connection with the characteristics at saturation. For the ferrite core, the inductance decreases steeply as the ambient temperature becomes high. On the contrary, the metal core has no significant change in the property of saturation current level with the ambient temperature change. Therefore, the metal core is highly reliable when used in a high-temperature environment. In the power supply circuit when switching, and loss in the inductors. It is recommended to choose inductors with low loss. The loss in the inductor can be due to the direct current resisting components or the material. When the load current is large, the percentage of loss due to the direct current resistance component of the inductor is large. When the load current is small, the percentage of loss due to the material is large. Power circuit efficiency is expressed as the ratio of output power to input power. In order to achieve a high-efficiency power supply, it is important to make an optimal selection of components affecting power loss. Taiyo Yuden provides the electronic component search site TY Compass on our official website. There is a various specification data available at this site.